Hello and welcome back to a new video and a new session in our continued journey of trying to master geometry. And our today's agenda is going to be transversals across the parallel lines and the concept of pairs of angles being equal to each other. But before we start this journey, I'm assuming that you're comfortable with the basic idea of angles. You know that when two lines intersect each other, the vertically opposite angles are equal to each other. And you also know that the sum of angles on a straight line is always going to be 180 degrees. This is the summary of the journey that we have done so far, because we'll be using those ideas to further derive new ideas and keep doing and keep repeating that process, right? So let's start the journey. First of all, what do I mean by a transversal? A transversal is a line cutting across two or more lines. So say this is line L and this is line M and this is line N. So in this story, N is the transversal line cutting across lines L and M. Now the moment I do that, remember when one line was cutting another line, I was getting 4 possible angles. Now I've got 8 possible angles. So let me name them also: 1, 2, 3, 4, 5, 6, 7 and 8. So before we go into the theory of transversal cutting across a parallel line, we just want to become comfortable with a few terms, and the terms being corresponding angles. What do I mean by a corresponding angle? In this story, angle 1 and angle 5 are corresponding angles. They're not equal to each other in this particular story, but they're corresponding to each other. That means that they are like each other, they are similar to each other. And how are they similar? If I look at angle 1 and angle 5, both of them are above the line and on left of the line. So that's the common thing between them. So they correspond with each other in terms of position or relative position, right? Similarly, angle 2 and angle 6 follow the same logic. So angle 2 and angle 6, also are a corresponding angle pair. Similarly, notice angle 4 and notice angle 8. Both of them are below the line on left side of the line N, so they also correspond with each other. So 4 and 8 is also a pair. And similarly, 3 and 7 is also a corresponding angle pair. So if you understand this term corresponding, the logic is very easy. You don't have to memorize it. You just have to look at pairs which are similar to each other in terms of placement, relative position, etc. So this is the set of corresponding angles. Similarly, I can make more pairs, connected pairs essentially. I can look at alternate angles. First of all, I can look at alternate interior angles. Interior means these are the two lines, this is the interior of the two lines and these sides are the exteriors. This is in the middle of these two lines, this is the enclosed space, therefore interior. And alternate means one angle is on the right side of the transversal, the other is on the left side. Right and left is not very important, just that they are on the alternate sides. So if I look at alternate interior angles, angle 3 and angle 5 are a pair. Why? Because they are both on the interior and I am saying alternate and I see they are on the alternate sides of the transversal. Similarly, angle 4 and angle 6 are also alternate interior angles or a pair of alternate interior angles. If I just remove this interior and I replace with exterior, that means I am talking about beyond the lines, right? Not between them but beyond them. So I can look at alternate exterior angles. That means if I look at angle 1, the alternate exterior is going to be angle 7, because angle 1 is on the left side of the transversal, so I am looking at an angle which is on the right side. So if I think of angle 1, the alternate exterior angle is going to be angle 7. Similarly, for angle 2 is going to be angle 8. Angle 2 is on the right side of the transversal, angle 8 is on the left side of the transversal, and both of them are on the exterior, so alternate exterior angles. And lastly, one more term, and don't worry about memorizing the term, try and see it on a common sense basis, it will be faster and easier, is interior angles on the same side of the transversal. So this is the transversal. These are the interior angles which are on the same side. Angle 3 and angle 6. Similarly, angle 4 and angle 5 also fall in the same category because both angle 4 and 5 are interior angles and they are on the same side of the transversal. So just recap the idea for yourself. When a transversal cuts across minimum of 2 lines, there are 8 possible angles created, and I want to look at a few pairs and the connection between them. So one such pair is the pair of corresponding angles. So we looked at angle 1 corresponds with angle 5, angle 2 corresponds with angle 6, angle 4 corresponds with angle 8, and angle 3 corresponds with angle 7. So these are corresponding angle pairs. Then we looked at alternate interior and try and understand the term. Alternate means on the either side of transversal. Interior means between the 2 lines. So alternate interior angles, angle 3 and angle 5. Angle 3 and angle 5 are alternate interior to each other, and angle 4 and angle 6 are also alternate interior to each other. I change the term to exterior, and then I see that angle 1 and angle 7 are alternate exterior angles. Angles 2 and angle 8 are also alternate exterior angles. So this is just understanding the term, because now when we move to the parallel line, we'll say stuff like corresponding angles are equal or alternate interior angles are equal. So we should know what these terms mean. That is the only use of knowing these terms and just getting familiar with the basic ideas. So now we come to the juicy part, and a very fairly important part in later applications also, because again a lot of future things will be derived from this idea, and it's a very easy idea as of now. So we are talking about a transversal. There is a line L and there is a line M, and the transversal is N, and it is cutting across 2 lines, and it is given that lines L and M are parallel. What does parallel mean? We have seen intersecting lines, and it could also be that I can't see the intersection, but I can see that they are going to intersect somewhere, right, in the future. So these lines, parallel lines, never intersect. The distance between them remains the same. If you measure the distance here and the distance is d, if you go ahead and measure the distance here, again the distance would also be d. Another way of looking at it is that imagine that instead of a line there is a scale, and I can physically move the scale. If you move the scale up and take it to this line, you will see that the angle between these 2 lines, I am moving this line here, the angle is 0. That means a relative rotation between them, because remember, an angle was giving me information about the rotation, how much movement across the circle is happening. This means that if you take the line and put it on top of the other line, the angle between them is 0, and that will remain the same. So lines L and M are parallel to each other, and N is a transversal cutting across these 2 lines. The first idea that we need to learn is that the pair of corresponding angles is going to be equal to each other. So if this was angle 1, angle 2, angle 3, angle 4, and this is angle 5, 6, 7 and 8, for starters, I am saying that angle 1 is equal to angle 5. Now, how do I come to this conclusion? What you can do is you can try this out for yourself. Draw 2 parallel lines, or open a standard notebook where there are ruled lines that are parallel to each other, and draw a transversal across it, and then measure these angles, and you will find them that they are equal to each other. And measure these angles, and you will find that they are equal to each other. So that is one way of proving by physical experience. You can draw multiple parallel lines, draw multiple transversals, and do it a few times to assure yourself that this angle and this angle in any scenario is going to be equal to each other. Another way that you can look at it is, if I take this line L and I just move it up or down, right? That means I'm not changing the rotation of the line, I'm just changing the physical placement. The angle, whatever angle it was making with the fixed reference is the same, or whatever angle it was making with any other line will remain the same. That means even if I move this line up and down, the angle is going to remain the same. I hope the animation also helps you see that. Once I see that, I can see that this line M is nothing but a copy of line L pulled down, and pulling down or pushing up does not change the angle. So using this, or intuitively, or by measuring, I can see angle 1 is equal to angle 5. Similarly, angle 2 is equal to angle 6. In fact, this you could have derived in other ways also. Once you take that angle 1 is equal to angle 5, You know angle 1 plus angle 2 is going to be 180. You know this is equal to angle 1 only. Angle 1 plus angle 6 is also going to be 180. And using that equation also you can say angle 2 is equal to angle 6. Now that's why we wanted to learn the term corresponding angles, because the moment I go to parallel lines, all the corresponding angles become equal to each other. So angle 1 is equal to angle 5, angle 2 is equal to angle 6, angle 4 is equal to angle 8, and angle 3 is equal to angle 7. So we'll see a lot more connections between these angles, but this is my foundation ground zero, that all the corresponding angles are equal to each other. Because once I know that, the other things I can again very quickly derive. Staying with the same parallel line, write down your results somewhere so far. Angle 1 is equal to angle 5, angle 2 is equal to angle 6, angle 4 is equal to angle 8, and angle 3 is equal to angle 7. Just keep this result on the side. The next result that I can go for, and it's a fairly important result used a lot, is that alternate angles are equal to each other. Alternate interior angles, let's say, are equal to each other. So I want to say that angle 3 is equal to angle 5. I know the corresponding angles are equal to each other, but how do I prove that this angle 5 is equal to angle 3? And I can do it very easily. Angle 1 and angle 3 are vertically opposite angles, something that we looked at in the last session. That means angle 1 is equal to angle 3. And we just looked at angle 1 is also equal to angle 5. So instead of angle 1, I can say angle 5. And therefore angle 5 is equal to angle 3. Once I know this, pretty much the same process is going to repeat here. Angle 4 is equal to angle 6. Do prove it for yourself. Angle 4 is equal to angle 2. Angle 2 is equal to angle 6 because they are corresponding angles, and therefore angle 4 is equal to angle 6. So the alternate interior angle, and remember this shape, because this shape will come in handy in a lot of problem solving, the Z shape. So these two angles are equal to each other, or you can create this Z shape and these two angles are equal to each other. So we know the corresponding pair of angles are equal to each other, and we also know the alternate interior angles are equal to each other. Let's look at alternate exterior angles now. And again, write down these results somewhere so that not only you know them and where they came from, they should be very familiar to you, so that next time you apply it in another problem when we say corresponding angles, you should know immediately what we're talking about. So this is not only easy but also fairly very important. So we have looked at corresponding angles, we looked at alternate interior angles. Let's draw this diagram again. Again, two parallel lines and the same transversal. And again the names are so again two parallel lines L and M, and there is a transversal cutting across. So we have looked at corresponding, we have looked at alternate interior. What about alternate exterior? What about angle 2 and angle 8? What can I say about them? And by now I should be able to make that jump very quickly. Angle 2 is going to be equal to angle 6 because of the corresponding pair, right? And I know that angle 6 is going to be equal to angle 8 because they are vertically opposite angles. So I can say angle 2 is also equal to angle 8. Similarly, angle 1 is equal to angle 7. Why? Because angle 1 is equal to angle 3. Angle 3 was equal to angle 7. Therefore angle 1 is equal to angle 7. So not only the alternate interior angles, the alternate exterior angles are also equal to each other. What else can we notice in the story? Again two lines, again the same. What else can we learn from this story? So we have looked at corresponding angles are equal, we have looked at alternate interior angles are equal, we looked at alternate exterior angles are also equal to each other. While discussing the terms, we also looked at interior angles on the same side of the transversal, angle 3 and angle 6. And I want to show that angle 3 plus angle 6 is going to be 180 degree. How can I do that? And by now the process should be fairly intuitive. You know angle 2 plus angle 3 is going to be 180 degree because this is a straight line and this is the big angle. You know this angle on a straight line is 180 degree. This angle is made up of angle 2 plus 3. So angle 2 plus angle 3 is equal to 180 degree. And you know instead of 2 you can write angle 6. So instead of 2 you can write angle 6. Angle 6 plus angle 3 is equal to 180 degree. And that's it. You proved it. So interior angles on the same side, the total of their angles is always going to be 180 degree. Can the same result be proven for angle 4 plus angle 5? Yes, it can be, using very much the same process. Angle 1 plus angle 4 is going to be 180 degree. Angle, instead of angle 1 I'll write angle 5 and I'll get angle 5 plus angle 4 is also going to be 180 degree. So that's it. That covers all our results when a transversal is cutting across a parallel line. The corresponding angles are equal to each other, and instead of memorizing the term, try and understand the term, that what do I mean by correspondence. So notice that angle 1 and angle 5 are very much alike. They correspond with each other. So all the corresponding angles were equal. We know the alternate interior angles are going to be equal. So angle 4 is equal to angle 6, angle 3 is equal to angle 5. We also know alternate exterior is going to be equal, and now finally we also know the sum of interior angles on the same side of the transversal is also going to be 180 degree. So go through this result a couple of times and you can try out very easy questions. Maybe a very basic question that you can do is draw a transversal across two parallels, and they say this angle is given. Using a single angle, can I find the rest of the angles? Try that for yourself and make a couple of different stories. Change the value, change the position of the angle and see what happens till you are very familiar and comfortable with these terms. Because first of all, we'll obviously look at a couple of problems just with this idea, but you will notice it over and over again as we move to triangles and quadrilaterals. Wherever we go, this idea of parallel lines and corresponding angles and alternate interior angles will come in handy over and over again. So be very comfortable with this. So this was the problem given to us. Lines PQ and RS are parallel to each other, and angle MXQ was given as 130 degree and angle RYM was given as 40 degree. And your question was, what is the value of angle YMX? So the lines are parallel to each other, but I don't have a common transversal. I have two transversals here, this one as well as this one. So there is not a direct connection happening. Obviously I can stretch it further here and start connecting things. Okay, this is 130 degree and then do more stuff, but let me not do that. Instead, let me draw a third parallel which is passing through M. Let me call it line A. So now line A is parallel to PQ as well as RS. There could be another interesting theory problem for you. It is given that PQ is parallel to RS, and let's say it is given that RS is parallel to line A. Prove that line PQ is parallel to line A. So start thinking about this problem for a little bit. It's going to be very easy to prove, but as of now I'm assuming that line A is parallel to PQ as well as parallel to RS, and let's see what we can do with the question first. Now if I look at this line and this line, this angle and this angle are the interior angles on the same side. So if I call it X, I know 130 plus X is equal to 180 degree. What is the result that I am using? Interior angles on the same side of the transversal, their sum is 180 degrees. So this part is 50 degrees, right? This angle is 50 degrees. And now if I forget this story and I look at line A parallel to line RS, I know this angle and this angle, notice the Z shape, are alternate interior angles. That means this angle is equal to this angle, which is 40 degree. And the angle that I wanted to find, the YMX angle, is the sum of these two angles. So I can very quickly say 50 plus 40 is going to be 90 degree. So my question is solved, fairly easy, just repeating the key ideas that alternate interior angles are equal to each other. The sum of interior angles on the same side is equal to 180 degree. And I hope you've been working on this problem. And the problem is that I give you a line PQ and I tell you that line RS is parallel to PQ, given that PQ is parallel to RS. And I give you a third line, XY, and I tell you it is also given that RS is parallel to XY. Prove that PQ is also parallel to XY. Now it is very intuitive, it is almost visible to me that this is the case, but how do I prove it? Draw a transversal across and just compare the angles. I know this angle is going to be equal to this angle because they are parallel and these are corresponding pairs of angles. And I know this angle is going to be equal to this angle. That means this angle is also equal to this angle. That means the corresponding angles are equal to each other, and I am using the same result backwards, that when the lines were parallel, the corresponding angles were equal to each other. The corresponding angles are equal to each other, that must mean that the lines are parallel to each other. The proof is as simple as that, and you could have gone for any theory and you can prove everything, because once you know, because as you noticed earlier, the moment you notice that the corresponding angles are equal, all other stories are also going to kick in, and that is very easy to derive. The idea being that the same results that you have derived from parallel to the connection between angles, you have the connection between angles, you can go back to the story that the lines are parallel to each other. That means if I tell you that there is a pair of lines and there is a transversal across and the alternate interior angles you notice are equal to each other, it wasn't given to you that the original lines are parallel, but it is given to you that the angles are equal to each other, you can conclude that the lines are parallel. Or it was given to you, I tell you that there are two lines, I do not tell you that they are parallel, but I tell you that this is 130 degree and this is 50 degree. So you add them up and you say, okay, these are 180 degrees. That means the sum of the angles on the, that means the sum of interior angles on the same side of the transversal is 180 degree. That means these two lines must be parallel to each other. That means we started off with parallel and derived the results about the angle. Now I'm using the information about the angle to derive whether the lines are parallel or not. A fairly easy proof, just covering it for the sake of completion. So this was the story given to us. Lines AB and CD are parallel to each other, as well as lines CD and EF are parallel to each other. So at the very onset, I can also say that line AB is also going to be line parallel to line EF. The other thing given to us is angle BAE is 90 degrees, and it is also given to me angle BEF is 55 degrees, and I am supposed to find the values of X and Y and Z. A fairly easy question, can be done fairly quickly. This is 55 degrees plus Y, because these are interior angles on the same side of the transversal. These are the parallel lines. These are the parallel lines EF and CD, and this is the transversal. So we are talking about the interior angles on the same side of the transversal. Just rotate this figure and you will see. So 55 plus Y is going to be 180. Y is going to be 125. 180 minus 55 will give you 125. Now if I look at line AB and line CD, these two angles are corresponding to each other. That means if this is 125 degrees, this also would be 125 degrees. So I've got the value of X, I've got the value of Y, I just have to figure out the value of Z now. And remember, as you try out these geometry questions, you will often see multiple ways of approaching them. Some people might see a triangle in here and start using the properties of triangle, but as of now, I just want to stick to transversal across a parallel line. Now notice that lines AB and line EF are also parallel to each other. That means, and the transversal is this line. These are the parallel lines and this is the transversal. That means this angle and overall this angle are the interior angles on the same side of the transversal. Same logic here. A and B and E and F. That means I can forget about this C and F for a minute, and I can also forget about this. So the diagram is more clear to me. This angle and this angle, once again the sum is going to be 180. 90, and this angle was made up of angle Z and angle 55. That means this angle was 55 plus Z. That means 90 plus Z plus 55 is equal to 180, and I can figure out the value of Z. That last step I'm leaving for you. So once again, a very simple story, but just instead of one line there were two lines and there were multiple angles to form. very basic practice to repeat the key ideas that we have learned so far. So this was a story given to us that lines PQ and lines ST are parallel to each other. An angle PQR is 110 degree, an angle RST is 130 degree. Find this angle. Again, using the same idea, draw a third line parallel to both the lines PQ and ST, or draw a line which is parallel to PQ and passing through R. This line will also be parallel to ST anyway. Now once I have two parallel lines, once again I can see this angle and this angle are the interior angles on the same side. So this angle plus this angle is going to give me 180 degrees. This is 130 degrees, so this must be 50 degrees. Now look at these two parallel lines. These are the interior angles. This is 110 degree, so this must be 70 degree. Now look at this line. You know all the angles on a straight line add up to 180 degree. 70 degree, 50 degree, 120 degree gone, so I'm left with 60 degree and I've got my answer. So I hope by now we are finding this kind of question very easy. Just draw a third parallel line and your job will be done. So this was the story given to us. Lines AB and CD are parallel to each other and EF is perpendicular to CD. Perpendicular means it creates an angle of 90 degree. And it was given to me that angle GED, this angle is 126 degrees. And the question was, what is the value of angle AGE? That means this angle. What is the value of angle GEF? GEF. And what is the value of angle FGE? FGE. So let's get started. I know angle GED is 126 degrees. But angle GED is made up of angle GEF plus FED. I know FED is 90 degrees, so 126 minus 90 degrees is going to give me angle GEF. 126 minus 90 gives me 36 degrees. I can very quickly see, and the direction does not matter, just keep taking the next step. I can see this whole arc is going to be 180 degrees. So 126 degrees is gone. Out of 180 degrees, how much am I left with? I'm left with 54 degrees. Now notice the parallel line, notice this angle and this angle. This is GE is the transversal across two parallel lines AB and CD. That means the sum of the angles on the interior on the same side of the transversal is going to be 180 degrees. That means 54 plus angle AGE, whatever this is going to be 180 degree. 54 plus what will give you 180 degrees? You just saw that 126 degrees will give you 180 degrees. Now once I have this as 126 degrees, or I could have also seen the Z shape and said that the alternate interior angles, this angle and this angle, are equal to each other. And if this is 90 degrees, I'm just playing with it now. If this is 90 degrees, this is also going to be 90 degrees because 90 plus 90 is going to give me 180. These are again interior angles on the same side of the transversal. If this is 90 degrees, this is a total of 180 degrees, this is 90 degrees, right? So once again, a fairly easy question can be done very quickly. So this was the story given to us. Line AB and line CD are parallel to each other, and line PQ and line PR are transversals on the parallels. The angle PRQ is given as the angle PRD is given as 127 degrees and the angle APQ is given as 50 degrees. You have to find the values of X and Y. Now some people who are already familiar with the triangle angle property, that sum of all angles is going to be 180 degrees, or if they are familiar that the exterior angle is equal to the sum of the opposite angles, they could have done this question even faster, but I still want to stick to transversals and parallels only, because we haven't done this yet. Even though this result itself will be derived from the theory of transversals and parallel lines, and we'll see that in a minute. So once again, what I'm trying to say is that there might be multiple approaches of doing so, but I am doing it according to the session agenda, that is to try and master transversals and parallels in detail and be very comfortable with it. So now if I look at the parallel lines and the transversal story, I see these two angles are the interior angles, and the sum of interior angles on the same side is equal to 180 degree. So whatever this angle was, 127 plus that angle was going to give me 180. So this angle is going to be 180 minus 127. That means it is going to be 53 degrees. Now if I look at this story, I know this is a full 180 degree. So 50 plus 53 plus y is going to give me 180 degrees. So I can figure out the value of y. Y is going to be 180 minus 103. That means it is going to be 77 degrees. Now think of angle x and again take PQ as the transversal. This angle and this angle are alternate interior angles. Think of the parallel and transversal, this angle and this angle, right? Again the Z shape. So this and this are equal to each other. So this is also going to be 50 degrees. So I've got everything. And without using the triangle logic or the exterior angle logic, just using the transversal and parallel lines. And once again, there could be multiple ways of playing with it. If this is 127 degrees, this was overall 180 degrees. So this angle is going to be 180 minus 127. That means 53 degrees. Once again, if this was 53 degrees, this would also be 53 degrees because these are alternate interior angles. And if this is 50 degrees, the sum of this 50 degree plus this angle was going to give you 180 degrees. So 50 degrees plus 53 plus y was going to give you 180 degrees. So once again you would get the value of y as 77. So once again the point being that there are multiple ways of approaching the problem, and this is without even using the angle sum property of the triangle or the exterior angle property. This is just playing with transversal and parallel so far. So I hope by now you are very comfortable with the ideas of transversals across parallel lines. And these terms like corresponding angle, interior angle, alternate interior angles on the same side, etc. are very comfortable to you by now. So now we want to extend that idea further and see that idea in action in trying to derive another very key important result. And we might be very familiar with the result already because this is a fairly basic idea. Even if I have not mastered geometry, I must have heard of this result a multiple number of times, and that is the sum of all angles in a triangle is 180 degrees. If this is angle A, this is angle B, this is angle C, I know angle A plus B plus C is equal to 180 degrees. Or I have seen this somewhere, or I have heard of this at least. So this is a result, but we obviously want to prove this result. How do I know that this is going to be 180 degrees? And what is the logic behind it? And the reason behind going every logic or why things are working the way they are working is so that we have a more sure-footed foundation and we develop this problem-solving attitude, which is essentially about asking why something is happening or how it is operating. Because once we develop that approach, any new kind of problem will just be another such challenge of thinking. So let's think about why angle A plus angle B plus angle C is equal to 180 degrees. And you can do it, you can prove it fairly quickly by using parallel lines and transversals. So just draw a parallel line. So say this is point A, point B and point C. Draw a parallel line L parallel to line AB. So this is a line AB extended if you want. And these are your transversals. Now very quickly, if this is the transversal, this angle and this angle will be equal to each other. Why? Again, notice the Z shape. This angle will be equal to this angle. That means this angle is going to be B. Or more formally, these are alternate interior angles and these are parallel lines and therefore they are equal to each other. Similarly, angle A will be equal to this angle. So this can be written as A. Why? Because again, for the parallel line L and line AB and the transversal CA, this angle and this angle are alternate interior angles. So this angle is A, this angle is B, this angle is C, and I can see this is once again a 180 degree angle. Why? Because any sum of angles on a line, on a straight line is 180 degrees, and therefore angle A plus angle B plus angle C is equal to 180 degree. Another advantage of coming to a result, a well-known result, by proving it, that not only you are more comfortable with the result, the result will also stay in your head longer compared to simply memorizing. And overall, this approach or this mindset should be developed of asking why as in hows. So this is how we prove that the sum of the angles of our triangle is going to be 180 degrees. And remember, we did not have values of A, B and C, so this will work for no matter what the situation is. We have drawn one particular triangle. We have tried the process with one particular triangle. You should repeat the process again. What if the triangle was looking different? How would the logic differ? You will see it will not differ as long as you draw two parallel lines and use the logic involved. Just returning to a question that we had seen earlier, not in too much detail, but just quickly going through it. We have done this question already. These are parallel lines. The sum of interior angles was going to be 180 degrees. If this is 55, this is going to be 125 degrees. If this is 125, this is also 125 degrees. Now my question was, what is the angle Z? Now for a minute, if I forget this and I mark it as Z, and now I notice a triangle at these 3 points. If this is 125 degrees, I using the 180 degree theorem, using the idea that a straight line is 180 degrees, this would be 55 degrees. Now I have a triangle and I have two angles given. So 90 plus 55 plus Z is going to give me 180. And once again, I find the value of Z. My point being that the same idea that any problem can be approached from multiple directions. And as you go ahead and move further in the topic, essentially your set of tools is increasing. Now you have one more tool to deal with the same problem, and you might be able to do it quicker or faster. The speed is not a very important aspect right now, but the idea being as you move deeper and higher in the theory, your set of tools is increasing. So the same problem that earlier might take 5 steps, later can be done in 1 or 2 steps very quickly, and each of this is a tool for you. So now not only you know that the corresponding angles are equal, the alternate interior angles are equal, the sum is 180, you also know if you can see a triangle and there are angles involved there, you have one more idea to use. So get comfortable with using these formulas as tools rather than a burden for yourself. So staying with the idea of these formulas as tools, a very common result tool that you'll be using is that if I extend the side of a triangle, this angle formed is known as the exterior angle. And say this angle is A and this angle is B, this exterior angle X is going to be equal to A plus B. So once again, a very common result, a lot of you might be already very familiar with this, that the exterior angle is equal to the sum of the opposite angles. But how do I prove this? And once again, it's going to be fairly easy. Let's say this angle was C. So you know C plus X is equal to 180 degrees. This time I won't even have to draw a parallel line or anything. C plus X is equal to 180. And I also see that C plus A plus B is equal to 180 degree. Forget about solving the equation for a minute. C plus something gives you 180. C plus something gives you 180. These two somethings must be equal to each other. And that is my result in this particular story. So once again, another important result that we'll be using a lot in our problem solving. Obviously, we saw that the sum of all the angles was 180 degrees. We are using that in this story. And now we know that the exterior angle is equal to the sum of these angles on the opposite side. You can practice a little more with this. This particular angle, let's say call this Q, will be equal to A plus C. This particular angle, call it Z, will be equal to B plus C. So whatever side we are talking about, the angles on the opposite side, the sum of it is going to be equal to the exterior angle. So this is the story given to us. There is a triangle PQR. It is given to me that QT is perpendicular to PR. That means this angle is 90 degree. It is further given to me that angle SPR, this angle is 30 degree. Angle SPR is equal to 30 degree. And angle SQT is equal to 40 degree. So this is the information given to me. And my question is, what is the value of angle X and angle Y? So how do I go about doing that? And remember, now our focus is on using the angle sum property or the exterior angle property, either of them. So for a minute, let me forget this line so that I can see a triangle very clearly. triangle QTR. If you want to, if you're a beginner, draw it out for yourself also so that you see things more clearly. This is angle X. Angle RQT or angle SQT, whatever you want to call it, is 40 degrees. So you have this angle, and this you know is 90 degree. This is 90 degree. So you have a triangle, you have two of the angles. Can you find the third angle? Yes, of course you can, because the sum is 180 degree. This is 90 plus 40, which is 130. 180 minus 130 is going to give you 50 degrees. So you have 50 degrees as your answer. So now draw the line again and come back and focus on angle Y. Now again, multiple ways of going about it, but for a minute notice this angle Y is the exterior angle for this particular triangle. That means if you think of the triangle P, S and R, the angle Y is an exterior angle. P, S and R, this angle Y is an exterior angle for this particular triangle. That means Y is going to be this angle plus this angle, the sum of the opposite angles. You know this is 30 and you know this is 50. So 30 plus 50 is going to be 80 degrees. So one simple question, and both the ideas got applied in this question, that the sum of the angles in a triangle is 180 degrees and the exterior angle, the value of it is the sum of the angles on the opposite side. So I hope you are getting more comfortable with this idea. So let's try one more question and stay with me till I build the story. There is a triangle ABC and this is given as 45 degrees, and this is Y and this is Z. You don't know the values. Then it says the side AB was extended up to point D and side AC was extended, and let's call it point D. And then two angle bisectors were taken, BO and CO. What is an angle bisector? It divides an angle into two equal parts. That means the angle CBE is being divided into or bisected into two parts. That means these two angles are equal to each other, and the same story is repeating here. These two angles are equal to each other. And my question is, what is the value of this angle? What is the value of angle BOC? So once again, this is a triangle given to us, ABC. The side AB was extended a little, side AD was extended a little. Then the angle CBE's angle bisector BO and angle BCD's angle bisector CO, they meet at point O. And your question is, what is angle BOC? So you can stop at this point and try the question by yourself. And how will you go about solving it? You know you have a few tools. What are the tools? You know that sum of angles on a straight line is 180 degrees. You know the sum of all the angles in a triangle is 180 degrees. Or you know that the exterior angle is equal to the sum of the angles on the opposite side. So these are some of the tools, but just start working with the problem and you'll see what to do. For example, I want to focus on this triangle BOC. So I want to look at angle CBO and angle BCO, because from 180 if I subtract these two angles, I'll get this value. So I'm thinking of angle CBO, angle CBO. Angle CBO is equal to half of, because angle bisector, that means this is half of this angle. BO is an angle bisector, that means this angle is half of this angle. Which angle? CBE. This big angle that is being formed, this is half of this. So angle CBE. Angle CBO is equal to half of angle CBE. Angle CBE itself was 180 minus Y, because this whole thing is 180. This is Y. So this angle CBE is going to be 180 minus Y. Angle CBO is equal to half of 180 minus Y. Keep this here. This will become 90 minus Y by 2. Play with this story now. Angle BCO, this angle is half of the bigger angle BCD. So this is equal to half of BCD. And angle BCD is 180 minus Z, because this whole angle is 180. If you subtract Z from it, you will get the rest of the story from this point to this point. So angle BCD is equal to 180 minus Z. solve it again, you will get 90 minus z by 2. So I've got the value of this angle in terms of y and in terms of z, and I can see now where the direction is going, because I will later use x plus y plus z is equal to 180 degrees, right? So write these stories somewhere and you have the values of this angle and this angle. Now if I focus on the triangle BOC, I know this angle, this angle, this angle is going to give me a sum of 180 degree. Let me call it angle O for a minute for easy reference. So forget this story, capture the key points, move on, and you will see this angle was 90 minus y by 2 plus this angle was 90 minus z by 2. So angle O is equal to 90 plus 90, 180. 180, 180 would get cancelled. Minus y by 2 minus z by 2 will switch and become plus y by 2 plus z by 2. So angle O is equal to y by 2 plus z by 2, or I can write it as angle O is equal to y plus z by 2. Now I can make a very quick jump. I know 180 is equal to x plus y plus z, or y plus z is equal to 180 minus 45, because x was given to me as 45. So instead of y plus z, I can write 180 minus 45, and that's it. So the value of angle O is going to be 180 minus 45, whatever that value is, divided by 2. So leaving that final step to you. In fact, the theoretical question was not even, this 45 was not even given. The question was, what is O in terms of x, or prove. That means instead of this 45, if you just write an x here, this will become 180 by 2, separate it out, it will become 90 minus x by 2. So this was given as a proof question. Prove that angle O is equal to 90 minus x by 2. So I'm just putting a value here so that it becomes more of a practical question. I can find the exact value of O. But once again, looks slightly bigger, looks slightly difficult, but I know I have a set number of tools. So let me try them one by one and see what works for me. Once again, some people might have done this question using the external angle property, but remember, these are interchangeable almost. So you would have said this angle is equal to x plus z, and this angle is equal to x plus y, and this is half of this and this is half of that. So very similar logic. Try it out by yourself and you will come down to the same result. The result will be this BOC will be 90 minus x by 2, or if you take it as 45, it will be 90 minus 45 by 2, whatever that value comes out as.